Hello everyone, my name is Stephen Thomas and this is my final project for CNIT 176. For this project, I built a web server using Raspberry Pi with a software-based RAID 1 array for redundancy. And throughout this project, I'll be walking you down through my process from the business case, the design decisions, to the architecture involved, and the steps I followed, how I tested it, and I'll also share some challenges I faced, what I learned, and how I can improve for next time. So, to start off with the business case, the goal of this project was to design and deploy a small scale yet reliable web server for lightweight hosting needs, such as blogs, landing pages, or even personal portfolios. These use cases are common for small businesses, startups, or tech hobbyists who don't want to rely on third party cloud hosting. And so a RAID 1 mirrors data across two drives. This means the server can survive the failure of one storage device without losing data or uptime, which, quite frankly, is a key requirement for any service exposed to the internet. It brings enterprise like redundancy to a personal low cost setup. The Raspberry Pi, with its small form factor and low power consumption, was the perfect platform for this project. It's cost effective. It's also energy efficient and flexible enough to support everything from web servers to IoT gateways. And I also ended up choosing WordPress as the content management system to make the project feel more realistic. Because WordPress powers over 40% of websites worldwide. So it's a great example of something businesses might actually want to self host. Now to the Raspberry Pi architecture. This project makes a simple use of multiple architecture layers of the Raspberry Pi that we studied in CNIT 176. So let me break this down for you piece by piece and show how each Pi's architecture played a key role. First, starting off with the CPU slash ISA. The Pi's ARM processor handles all the application logic, from the Apache handling HTTP requests to the PHP rendering dynamic WordPress pages to the MDADM syncing RAID data in the background. Secondly, we have the USB input slash output controller. This allows two USB flash drives to be connected and used for the RAID array. It's not just about plugging in storage. The controller manages concurrent data writes across the mirrored disk. Then we have the file system management. I use tools like fdisk and mkfs to partition and format the drives. Then I used MDADM to create the software RAID and mount to integrate it into a file system hierarchy. All of this required a deep understanding of how Linux interacts with physical storage. Next, I had a networking stack. The LAMP stack runs over the TCP/IP, which is handled by the Pi's built-in networking interfaces. Apache serves HTML and PHP content, and then MariaDB communicates with WordPress, and everything flows over standard HTTP ports. And lastly, we have the user controlled interface. Finally, I did all the configuration work using tools like Linux CLI tools. This included editing such as the slash etc slash fstab, creating a symbolic links between the ln and slash s, and checking systems with health with mdadm detail. All of this reflects the Linux system administration concepts we covered during this course. Now, the procedures followed was how I built everything from the ground up. I started with a clean install of the Raspberry Pi OS and ran a full system update. Using fdisk, I partitioned two identical USB flash drives, and it's important that both drives be the same size and block format for RAID 1 to work correctly. Then, I created a soft RAID 1 array using MDADM dash dash create, specifying both partitions. Once synced, I formatted the array as ext4 and mounted it to the /mnt /raid 0. I then proceeded to install LAMP stack with Apache, MariaDB, and PHP using apt. I hardened the MariaDB installation by running secure setup script. I then downloaded WordPress, extracted it, and configured the wp/config.php file to connect to the database. And then to integrate the RAID, I moved the entire wp-content directory, which stores uploads, themes, and plugins, onto the RAID volume. Then I use a symbolic link so that WordPress still thinks it's accessing wp-content in its normal location, but it's actually reading and writing to the RAID array. Now moving on to my results, as you can see from my results, I could access the WordPress site from any browser on my network, and to my left is the Apache Debian default page. To my right are the following Linux command codes that I used to make the RAID array system working. I I tested the RAID one by integrity by showing if it appeared on both USB drives and then unplugging one drive. And even when I did that, the system stayed live and no data was lost, proving that the RAID 1 setup worked. And then you can also confirm this because at the end, the last image it shows how the lost plus found command is shown, therefore showing how the drive's health was in, how the entire system was working, and at the end proving how the RAID 1 system worked. Now, moving on to the troubleshooting part. Even though I ended up finishing the project successfully, I ran into a fair number of challenges that taught me a lot about debugging Linux systems. Firstly, the MariaDB authentication error. The secure installation wouldn't accept the root password, so I had to start MariaDB in safe mode, skip grant tables, and reset the password multiple times using the SQL commands before it ended up working. Then, the RAID array not mounting on boot was quite annoying. I noticed that the RAID volume wasn't auto mounting after reboot, and the solution to get was that the UUID of the array using the BLK ID and update it to the /etc/fstab with the correct mount instruction. Afterwards, the third error I faced was the RAID creation failure. Initially, the MDADM gave an error because I had forgotten to set the partition type to Linux RAID Auto Detect. I had to go back and recreate the partitions with the correct type using fdisk. Then I also had a lot of Wi-Fi dropouts. At one point, the SSH sessions kept dropping, so I had to move to a wired connection temporarily while performing disk-intensive operations. And finally, I was quite resource busy because I had to share the flash drives and from one of my other friends, so I had to wait for him to finish and then I was able to use it. And because I didn't have the resources at first, it delayed my initial start time of the project. But eventually, I persevered through all the errors listed in this presentation, and by working hard, I was able to finish the project successfully. These problems pushed me into a deep dive into the Linux logs and configuration files, and I came out of it with more confident in Linux administration and storage systems. And finally, with the lessons learned. The project gave me a hands-on experience with how software RAID works and why it's useful on simple hardware like Raspberry Pi. I also learned how important it is to understand the Linux tool process, file system, mounting, and permission models. These kind of details are the ones that make or break a stable server. If I were able to take this project further, I would personally add an automated offsite backup using rsync and a cron job. I would integrate a UPS to handle power outages more gracefully, and maybe I would add a dashboard using Grafana to monitor disk health and uptime. In short, this wasn't just about building a web server, but it was about building one that could survive real-time problems at the end. And so, thank you so much for watching my presentation, and I hope you enjoyed it. This project challenged me both technically and gave me practical experience with Linux web hosting and storage resilience, and helped me apply my concepts from CNIT 176 in a real world scenario. I had a lot of fun. Thank you.